During this presentation, we have to derive the Schwartz inequality. The statement of Schwartz inequality is the absolute value of the scalar product of state vectors psi1 and psi2 is less than or equal to the product of the norms of the states psi1 and psi2. Mathematically, we can write modulus of psi1 psi2. This is the scalar product is less than or equal to norm of psi1 into norm of psi2. Now we should know the meaning of the term scalar product. Scalar product of psi1 and psi2 is inside the bracket we have to write psi1 comma psi2. The meaning of psi1 here is psi1 star. Psi2 is mere psi2. This is actually draw psi1, get off psi2. Then psi1, psi2. This is scalar product which is equal to integral psi1 star psi2 into d tau. This is the meaning for scalar product of psi1 and psi2. Now, we should know the meaning of norm of psi. Norm of psi which is equal to square root of scalar product of psi with itself. Now we may write down the definition for norm of a state vector. The positive square root of the scalar product of psi with itself is called the norm of psi. That is, norm of psi equal to square root of the scalar product of psi with itself. In the same manner, we may write norm of psi1 which is equal to square root of scalar product of psi1 with itself. Then norm of psi2 which is equal to square root of scalar product of psi2 with itself. Now, norm square of psi which is equal to scalar product of psi with itself. This root is cancelled out. This is equal to psi star psi into d tau. If norm of psi equal to 1, then the wave function is said to be normalized. If the norm value is unity, the wave function is said to be normalized. In the same manner, you may write norm square of psi1 which is equal to psi1 comma psi1 which is equal to psi1 star psi1 into d tau. Norm square of psi2 which is equal to psi2 comma psi2, that is scalar product of psi2 with itself, which is equal to psi2 star psi2 into d tau. These are all the things needed to understand this statement. the absolute value of the scalar product of the state vector psi1 and psi2. Scalar product of the state vector psi1 and psi2 is written inside the bracket. Absolute value means just we have to take the determinant. The absolute value of the scalar product of the state vector psi1 and psi2 is less than or equal to, this is called inequality, less than or equal to the product of norms of the states psi1 and psi2. Norm of psi1, norm of psi2. Now we have to prove this statement. For that, consider psi1 and psi2 are two eigenstates. Then their linear combination is also an eigenstate. That is psi, which is equal to psi1 plus lambda into psi2. It is also an eigenstate. Psi equal to psi1 plus lambda into psi2. Here lambda is a real number. Now taking norm on both sides, say this is equation 1. Taking norm on both sides of equation 1, norm of psi, which is equal to norm of psi 1 lambda, norm of psi 1 plus lambda psi 2. Say this is equation 2. Now squaring on both sides of equation 2, or we may write norm of psi 1 plus lambda into psi 2 is always a real quantity. If you take norm of a vector, that should be a real quantity. Therefore, we may write norm of psi 1 plus lambda into psi 2, which is greater than or equal to 0. See, norm of psi 1 plus lambda into psi 2 is always a real quantity. Real quantity means which may be equal to 0 or greater than 0. So keep this one as equation 3. Now take the square on both sides. You may write norm square of psi 1 plus lambda into psi 2, which is greater than or equal to 0. This is equation 4. Now we have to write the value of norm square of psi 1 plus lambda into psi 2, which is equal to integral psi 1 plus lambda into psi 2 star into psi 1 plus lambda into psi 2 into d tau. This is the meaning, because norm of psi in general, which is equal to square root of scalar product of psi with itself. But norm square of psi, which is equal to psi comma psi, scalar product of psi with itself. This is equal to psi star psi into d tau. Just we have followed the same logic. Entire is treated as psi. Norm square of psi, which is equal to scalar product of psi with itself, which is equal to psi star psi d tau. So norm square of psi 1 plus lambda into psi 2 equal to psi 1 plus lambda into psi 2 star multiplied by psi 1 plus lambda into psi 2 into d tau. Now we have to expand this. That is norm square of psi 1 plus lambda into psi 2, which is equal to psi 1 plus lambda into psi 2 star psi 1 plus lambda into psi 2 into d tau, which is equal to psi 1 star into psi 1 d tau plus psi 1 star lambda psi 2 d tau. So take the lambda outside. Psi 1 star psi 2 into d tau plus lambda into psi 2 star this psi 1 into d tau plus lambda into lambda, lambda square psi 2 star this psi 2 into d tau. This is the value of norm square of psi 1 plus lambda into psi 2. Now come to our equation 4. Equation 4 is norm square of psi 1 plus lambda into psi 2 greater than or equal to 0. Norm square of psi 1 plus lambda into psi 2 is greater than or equal to 0. Now write down equation 4. Psi 1 plus lambda into psi 2 see here norm square of psi 1 plus lambda into psi 2 is greater than or equal to 0. This is equation 4. But actually norm square of psi 1 plus lambda into psi 2 value is this much. Now equation 4 becomes psi 1 star psi 1 d tau plus lambda into psi 1 star psi 2 d tau plus lambda into psi 2 star psi 1 d tau plus lambda square psi 2 star psi 2 d tau is greater than or equal to 0. This is equation 5. Just we have substituted the value of norm square of psi 1 plus lambda into psi 2. Now we have to modify this. This is our norm square of psi 1. Because we may write this one as psi 1 comma psi 1. That's the meaning of this. Psi 1 comma psi 1 is norm square of psi 1 plus lambda into this is psi 1 comma psi 2 plus lambda into this is psi 2 comma psi 1 plus lambda square into, this is our norm square of psi 2, because this is actually psi 2 comma psi 2, lambda square into psi 2 comma psi 2, this is psi 2 comma psi 2, so that this is norm square of psi 2 is greater than or equal to 0. This equation 5 is modified in this form. Now norm square of psi 1 plus lambda into psi 1 comma psi 2 plus lambda into, see this psi 2 comma psi 1 is changed as psi 1 comma psi 2 whole star, then this term lambda square to norm square of psi 2 is greater than or equal to 0. But psi 1 comma psi 2 plus psi 1 comma psi 2 whole star equal to 2 times real part of psi 1 comma psi 2. A separate proof is available for this. We will discuss the same at the end of the session. This is a very, very important point. Now we have to apply this rule in the above expression. Say this is equation 6. In equation 6 we have to apply this. Norm square of psi 1 plus, instead of psi 1 comma psi 2 plus psi 1 comma psi 2 star, we can write 2 times real part of psi 1 comma psi 2. Already lambda is present here, so that 2 lambda real part of psi 1 comma psi 2. Instead of this, we have to write 2 times lambda into real part of psi 1 comma psi 2 plus lambda square, then absolute square of norm square of psi 2 greater than or equal to 0. Now we have to modify this in a convenient form. I don't this lambda square first. Lambda square, then norm square of psi 2 plus 2 lambda, the real part of psi 1 comma psi 2 plus norm square of psi 1 greater than or equal to 0. This is equation number 7. So this quadratic equation, the equation 7 is acceptable if delta, which is equal to b square minus 4ac, is less than or equal to 0. Equation 7 is a quadratic equation. This equation in this form 7 is acceptable if the value of b square minus 4ac is less than or equal to 0. If it is a case, see here, this is in the form of ax square plus bx plus c greater than or equal to 0. Here b is 2 times real part of psi 1 comma psi 2. This is b. A is norm square of psi 2 C is norm square of psi 1. Now we may write, apply this condition. So this is equation 8. The equation 7 is acceptable one if the value of b square minus 4ac is less than or equal to 0. Only under this condition, the equation 7 is acceptable one. If it is the case, we may write we need b square minus 4ac should be less than or equal to 0. B square, that is 4 into real part of psi 1 comma psi 2 whole square minus 4 into absolute square of psi 2, then the c. A is psi 2, c is absolute square of psi 1. Absolute square of, norm square of psi 1. B square, that is 4 into real part of psi 1 psi 2 square minus 4 into the value of A is norm square of psi 2, then the value of C is norm square of psi 1. These are all less than or equal to 0. Now we may write 4 into real part of psi 1 comma psi 2 whole square less than or equal to, bring this 4 into norm square of psi 2 into norm square of psi 1. Now we may write real part of psi 1 psi 2, 4 cancelled out, then cancel the squares. Real part of psi 1 comma psi 2 less than or equal to norm of psi 2 into norm of psi 1. Just to cancel 4 and 4, then take the square root on both sides. Real part of psi 1 comma psi 2 equal to norm of psi 2 into norm of psi 1. So this is equation number 9. The equation 9 is acceptable for all values of real part of psi 1 comma psi 2. The maximum value of real part of psi 1 comma psi 2 is modulus of psi 1 comma psi 2. The scalar product of psi 1 comma psi 2 inside the modulus is the maximum value of real part of psi 1 comma psi 2. Therefore, equation 9 becomes, instead of real part of psi 1 comma psi 2, we have to write its maximum value. Modulus of scalar product of psi 1 and psi 2. Then less than or equal to norm of psi 1 into norm of psi 2, which is our Schwartz inequality. The absolute value of the scalar product of psi 1 and psi 2 is less than or equal to the product of the norms of psi 1 and psi 2. This is our Schwartz inequality. Now, as stated earlier, we may prove the scalar product of psi 1 and psi 2 plus the scalar product of psi 1 psi 2 star, which is equal to 2 into real part of psi 1 comma psi 2. Let me present this one. Psi 1 comma psi 2 plus psi 1 comma psi 2 star equal to 2 times real part of psi 1 comma psi 2. Now, first of all, find out the real part of psi 1 psi 2. For that, assume that psi 1 equal to a1 plus I into b1, psi 2 which is equal to a2 plus I into b2. Then psi 1 star equal to a1 minus I into b1, psi 2 star equal to a2 minus I into b2. Now find out the scalar product of psi 1 psi 2. This is equal to psi 1 star psi 2 into d tau, which is equal to the value of psi 1 star is a1 minus I into b1. Psi 2 is a2 plus I into b2 into d tau, which is equal to a1 a2 plus I into a1 b2 minus I into b1 a2 I into I square is minus 1, minus into minus plus b1 b2 entire is multiplied by d tau. This is equal to integral a1 a2 plus b1 b2 plus I into a1 b2 minus b1 a2 into d tau. This is psi 1 comma psi 2. Now real part of psi 1 comma psi 2, which is equal to a1 a2 plus b1 b2 into d tau. This is real part of psi 1 comma psi 2. Now we have to prove that psi 1 comma psi 2 plus psi 1 comma psi 2 whole star equal to 2 times real part of psi 1 psi 2. See here, psi 1 comma psi 2, psi 1 comma psi 2 equal to, this is the value of psi 1 comma psi 2. a1 a2 plus b1 b2 plus I into a1 b2 minus b1 a2 into d tau. This is psi 1 comma psi 2. Now we have to find out psi 1 comma psi 2 whole star. Psi 1 comma psi 2 whole star, which is equal to integral of psi 2 star psi 1 into d tau, which is equal to the value of psi 2 star is a2 minus I into b2. The value of psi 1 is a1 plus I into b1 into d tau, which is equal to a2 a1 plus I into a2 b1 minus I into b2 a1 plus b2 b1 into d tau. This is integral of a2 a1 plus b2 b1 plus I into a2 b1 minus b2 a1 entire is multiplied by theta. Here also we have to bracket. Now find out the value of psi 1 psi 2 plus psi 1 psi 2 whole star, which is equal to, this is psi 1 psi 2, that is a1 a2 plus b1 b2. Here also a1 a2 plus b1 b2. I terms are in positive, a1 b2 minus b1 a2, a1 b2. These quantities are in negative, so items are cancelled out. This is equal to 2 times a1 a2 plus b1 b2 into d tau. Already real part of here, real part of psi 1 comma psi 2 is a1 a2 plus b1 b2 d tau, a1 a2 plus b1 b2 into d tau. This is our real part of psi 1 comma psi 2. Therefore psi 1 comma psi 2 plus psi 1 comma psi 2 whole star, which is equal to 2 times real part of psi 1 comma psi 2. So that in the presentation we have used the formula psi 1 comma psi 2 plus psi 1 comma psi 2 whole star is equal to 2 times the real part of psi 1 comma psi 2. That's all about the Schwartz inequality.